See question number 5 in exercise 8.2. The chapter is for quadrilaterals. Now in question number 5, you have to thoroughly read the question. It is given that ABCD is a parallelogram and DB is one of its diagonal. F is midpoint of DC and E is midpoint of AB. Now joining AF and EC. Okay. The diagonal is cut at P and Q. Now, what to prove is at this point the diagonal BD is trisected. Trisected means 3 equal parts. That means BQ is equal to QP is equal to BD. Now, how to prove? Let's start. Now, you must know it is given in the question that F is midpoint of DC. That means FC is half of DC. So I have written FC is half of DC. Also, DC is parallel to AB. So FC must be parallel to AE because AE is a part of AB. Again, DC is equal to AB. Why? Because of opposite pair of sides in the parallelogram. That's why half of DC is half of AB. Must be equal. Half of AB is half of DC, but we must have known here that half of AB is AE and half of DC is FC. So AE not only is equal to FC but also parallel because these two are pair of parts of pairs of parallel sides. So now we have AE is parallel to FC and both are equal. Now you have to note all these. Now come to what? That AECF. AECF. It is a quadrilateral in which one pair of opposite sides are not only parallel but equal. That's why AECF is a parallelogram. Now after proving that AECF is a parallelogram, you can proceed that EC is parallel to AF. EC is parallel to AF. Okay? Now, if EC is parallel to AF or AF is parallel to EC, the same thing. Now, if EC is parallel to AF, so part of AF is PF is also parallel to part of EC, that is QC. So, PF is parallel to QC in triangle DQC. You must have an idea of the converse of the midpoint theorem. The converse of midpoint theorem is that if a line is drawn through midpoint of a side in a triangle and parallel to the third side, then it will pass through the midpoint of the last side. So F is midpoint of DC in triangle DQC. In triangle DQC, F is midpoint of DC and PF is parallel to QC. That's why the conditions of converse of midpoint theorem are satisfying. So the result follows as PF, where P is a point where the line cuts DQ at P, is the midpoint of DQ as the result of the converse of midpoint theorem states. So P is midpoint of DQ in triangle DQC. If P is midpoint of DQ means DP is PQ. Okay. Now this is proved in triangle DQC. Now come to the lower triangle APB. In triangle APB, you can see here in triangle APB. Again Q is midpoint of, E is midpoint of AB. It is given. AB is the original side of the given parallelogram. E is the midpoint of AB. And as you proved that PF is parallel to QC, you can prove that AP is parallel to EQ. Okay? AP is parallel to UQ. You don't need to write the other steps because they are similar as in the triangle DQC. So you can write similarly. The word similarly we can show that EQ is parallel to AP. So if EQ is parallel to AP and Q is midpoint of BP, so converse of the midpoint theorem are fulfilled. So the result follows that E is the midpoint of AB. Q is the midpoint of PB. If Q is midpoint of PB means PQ is equal to QB, PB is equal to QB. This is equation number 4, and here you have written in equation number 3 that DP is parallel to PQ. So DP is equal to PQ and PQ is equal to BQ means DP is equal to PQ is equal to BQ. Okay, now come to the original figure. DP is equal to PQ is equal to QB. That means the whole diagonal is trisected by the points P and Q. This have to be proved. Now come to the question number 7, in which it is given that in triangle ACB, C is the vertex where right angle is formed. Now M is the midpoint of the hypotenuse AB, and a line parallel to the base BC is drawn which cut the side AC at D. Now what to prove? That D is midpoint of AC. This is the first part. You must be knowing that the converse of midpoint theorem states that if a line is drawn to the midpoint of one of the sides and parallel to another side, then it will cut the third side at its midpoint. So clearly, as the result follows, D is midpoint of AC. Okay, just by naming the converse of midpoint theorem, you can directly write D is midpoint of AC. Now, the second part is MD is perpendicular to AC. You know, it is given that DM is parallel to BC, and so angle C and angle ADM are corresponding angles, so they must be equal. If C is 90, so this angle must be 90. That means DM is perpendicular to AC. Okay, DM is perpendicular to AC. It is given here. Now the third part, what to prove? That if C is joined to M, to prove that CM is MA is half of the whole side AB. Now, joining CM in triangle ADM and in triangle CDM, you have the two triangles where DM is the common side. So write DM is equal to M the common side, and you have proved in second part that this angle is 90. DM is perpendicular to AC means this angle ADM is 90. So this angle in this triangle and this angle in this lower triangle, both are 90. DM is common and AD is equal to DC. So side, angle, side, SAS. So by SAS, the two triangles becomes congruent. If they becomes congruent, then by CPCT, their corresponding parts are equal. So AM is equal to CM. Just write here by CPCT. If AM is equal to CM, and earlier you have proved, or it is given, that AM, what type of M was? M was the midpoint of AB. So AM is half of AB. AM plus BM is AB, but BM is equal to AB, AM. So AM plus AM is AB, that is twice of AM is AB. So AM is half of AB. And by CPCT, you have proved that AM is equal to CM. So if AM is half of AB, so CM is also half of AB. So concluding this, you can prove the third part.